Hello and welcome back to differential equations. We are starting chapter 4 on Laplace transforms. One of the most used and abused techniques to solve differential equations by engineers. Probably one of the favorites. Well, now you have all the tech stuff that's coming in, so, right? But at the end of the days when you had to do everything by hand, Laplace transforms was one of the favorite quick and dirty techniques. And we'll see what's so awesome about Laplace transforms. So first of all, let's talk about the idea of substitution versus the transformation, because it is important to understand that transformations are different creatures. You can substitute certain things, plug in, right? And you have a variable, let's say x, which can take on any value, any number. So I can take 2, I can take 1/2, and so on. We have algebraic equation which can embrace that x. So we start with numbers. Then we add operations. And the unity of those will give us algebra. Well, sorry, and variables. And then unity of those will give us algebra. And then the algebra grows into functions on which you apply calculus. Some kind of a map. Now calculus branches into ordinary differential equations and other stuff. So when you think about this, you had that y is equal to f of x. Then you have that f of x, which is a function, is maybe x squared plus 3. And you compute that f of 5 is 25 plus 3 equals to 28, right? So this is something that we have for our kind of introduction. We have a function, and then that function can be computed. So this is us substituting values into an expression, into a function. Now what I can do is I can do substitution, and if I do substitution, let's say u is equal to, x is equal to u minus 1, then f of u minus 1 now is u minus 1 squared plus 3. This is substitution. Now if you observe, the function will change, right? And what I'm doing now is I am changing my input in terms of, I'm changing my input, right? So the variable that it's input now is no longer x, it's now u. So if you think about this, I can work this out and get u squared minus 2u plus 1 plus 3, which is u squared minus 2u plus 4. Now my question is, looking at this, which number do I have to plug in into f of u minus 1 to get 28? Which number for u I have to plug in to get 28? Yeah? 6, right? So if I have u equals to 6, then I am computing this as 6 squared minus 2 times 6 plus 4, which is 36 minus 12 plus 4, which is 28. So there was this substitution that happened. Now, transformations would change the input variable, the output variable, and the domain, and the function. So in a true light, the transformations changes everything. You see, over here, what we did is we had a function, and the skeleton of that function is still with us. When we work it out as the algebra, it doesn't look actually the same, but you can use completing the square and compress it back into it. For Laplace transform, we are going to take a differential equation which contains functions and derivatives and transform that into algebraic equation that has a variable. So I see you see that it's a complete. So OBS reconnection successful? What? We lost the connection? I don't know. Stream. Yeah, the OBS is behaving. I don't know. Anyway, talk about Laplace and we'll see. If the stream is there, it's there. So first of all, what is happening with Laplace transforms? So this is in a nutshell what happens. You have ordinary differential equation. You will plug that into the Laplace machine. This is the let's see if it works. It works. All right, so let's try transforming function 1. You know how to graph this function. T-axis, right? And that's just 1. It's a linear, horizontal linear line. So when we integrate e to the minus problem, which is e to the negative st over negative s, computed from 0 to b. So this is going to be e to the negative b. I hope that you understand that what we are doing here is we are transforming one type of a function into another type of a function because we need it for we see what. So Laplace transform, and we should keep track of these things. You do get the